Okay, logarithmic functions. So I'm going to highlight some important things in yellow. Some of these examples I'm not actually going to go over right at the moment. You'll see them later on. But what I want you to get out of this is how closely related logarithms and exponential functions are. So this exponential function, this logarithm, very closely related. And to do logs, particularly without a calculator, which you probably will have to do, you'll have to be able to think exponentially. Domain for logarithms are all logarithmic functions are the positive real numbers, and its range are all real numbers. Well, if you think about exponentials, the domain's all real numbers, and the range is all positive real numbers. They're inverses of each other. So here's some examples of some inverses. F of x is equal to exponential function 7 to the x. Well, f inverse is log base 7 of x. They're different functions, but they're really linked. And to think about this, it's easier to think about this one. Here's another one. 10 to the x is equal to g inverse of log. I don't have to put the 10 here because this is a common log. Any logarithm that's written like this, there's assumed to be a 10 there. It's a common log. So they're inverses of each other. Here's another one. I haven't gotten to this in class yet. But e to the x, the inverse of that is ln x, because ln is log base e of x. They're inverses. So when you're given a logarithm like this, log base 5 of 125, I will add equal to x, and I'll think about it this way. I'm going to change this into an exponential. This means 5 to this variable is equal to 125. That's what I have here. And when you do that, it's easier to think about. What do I have to raise 5 to in order to get 125? Well, x cubed. So some of these examples I'm going to go through now. Some I'm going to skip. Some are a little tougher than I intended at the moment. So I'm going to jump right down to this one here. Log base 12 of 1 is equal to x. Rewrite it as exponential. That means 12 to the x is equal to 1. So 12 to the x is equal to 1. Well, that's only going to happen when x is equal to 0. So if I do look at one of these more complicated ones, we can attack it the same way. Here's my logarithm. I'm going to change it to an exponential. 6 to the x is equal to 1 over 36. Now, I work through this in kind of a traditional way, and there's nothing wrong with it. Sometimes it's easier to think about what do I raise x to, 6 to the x to, in order to get 36. Not necessarily 1 over 36, but just 36. Well, 6 squared is 36. Well, when it's on the bottom, that would mean 6 to the negative 2. The negative would flip it, and the 2 would square it. Now, if I don't want to do it that way, I could work it like this. Just rewrite this with a negative exponent. Try to write 36 as something with a 6. So here's 6 squared. And working with properties of exponents, I can get the same answer. The next one, log base 64 of 4 equals x. Well, when this number is smaller than that number, and it's not a ratio, odds are it's going to be a root of some sort. So if I look at this, 64 to the x equals 4, I could go through this method here, rewrite 64 as 4 to some x, or 4 power. So in this case, 4 cubed to the x equals 4. So that implies that 3x is equal to 1, x equals 1/3. There's nothing wrong with doing this. This is a traditional way. But I would ask you to think about this. If I start taking roots of 64, it doesn't take you very long to get, the third root of 64 is 4th. So the cube root. So this would be equal to 1/3. Here's an example. I haven't done this in class. ln e to the 10 equals x. Well, this is log base e of e to the 10. The ln and the e are going to invert each other off, and I'm going to be left with 10. E to the x equals e to the 10. The only way that can be true is if 10 is equal to x. There's different ways of thinking about it, but I like to think exponentially. Okay, properties of logarithms. We have 3 properties. In class, I use different variables, but it's the same deal. If I have the log of some 2 things that are being multiplied, that's equal to the sum of the logs. If they're being divided, it's equal to the difference of the logs. If I have a log with an exponent on this term right here, that value, then I can rewrite it with the n in front. This property is the most important one. Here's an example of how you can use it. If I have log base 5 of 8, I can't take 5 to some exponent x and set it equal to 8 and do that in my head. That's not happening. But if I were to take the log of both sides, okay, whatever I do this side, I do that one. If I do the logarithm, that is called a monotonic function. That means you can do that. Look right here. I can apply property 3, and that allows me to move that x to the front. So I get x log 5 equals log 8. And if I just divide by log 5, this would give me what this exponent would be. This is solving equations, and I'm not going to dwell on that in this video. I just wanted to show you. But this drop on down to maybe this one right here. So I have log base 2, 4 squared, 3 to the 4th. And I'm just going to cruise through this using property 1 to begin with. Property 1, if this is a multiplication, I can rewrite that as a sum. So instead of log base 2 of 4 squared times 3 to the 4, I get log base 2 of 4 squared plus log base 2 of 3 to the 4. Property 3 allows me to move these exponents down in front. So that's now why I have 2 log base 2 of 4 plus 4 log base 2 of 3. In the next step, this log base 2 of 4 turns into a 2. And that's because 2 squared is 4. So that's why the whole thing's equal to 2. And I can simplify. The next one is a little bit simpler looking. I have log base 6 of 6 times x. I can break it up using property 1. I look at the log base 6 of 6. Well, that's equal to 1. 6 to the first power is 6. That's what the logarithm's looking for, is the power. Here's a couple more. If I look at, let's get rid of this one for a second. Let's just look here. I have ln of x times y over z. Sometimes I can put these in parentheses. And it kind of depends on what the book's doing, what the instructor's doing. I don't particularly care that much if it's all one entity, one term right there. But if I have it in parentheses or not, I'm going to look at that division, and I'm going to say, oh, that's property 2. So I'm going to rewrite that as ln xy minus ln z. I can apply property 1 to this term and get ln x plus ln y minus ln z. So regardless of what the logs are, you can still apply those properties. Here's some uglier ones. And if I look at that one, that's pretty ugly, but it has a division. And I'm going to start with the division, ln x minus ln of the denominator. And then I'm looking at this exponent here. Remember, a half means square root. But it's still an exponent, and I can apply property 3 to move that to the front, and I get this. And here they're trying to trick you. You want to be very careful. ln of x squared plus 1, I can't do anything with that. I can't distribute that ln in. That is what it is, and you can't simplify it any further. Okay, so here's a more complicated looking one. I have a product to an exponent. So the exponent's on the very outside, so I'm going to apply property 3 to move that 1/2 to the front. You notice I put it all in parentheses. I'm now going to apply property 1 to break up the product. I'm going to apply property, or the distributive property, to multiply the half in. And I also brought this 2 down. Where did that 2 come from right there? Well, that came from that 2 here. Technically 2 came down, then I multiplied a half in. Half times a 2, next step is a 1. And ln of x plus 2, I can't do anything to it. So pause it, go back through it, check it, see if that makes sense. If you have products, they're going to turn into additions. If you have an exponent, that's going to move to the front. You just have to be careful in the sequence of events when that happens. Now, the next part is to go backwards. And sometimes the problems will say, write these as a single logarithm. So now I'm going to take this, which is log base 5 of y plus log base 5 of x. They're separated by addition. Well, I can go backwards with property 1 and rewrite that as log base 5 of y times x. Next one has a subtract in it. So that's log, so it's common log base 10. So it's common log 4 by common log z. Well, minus indicates I'm going to do log of 4 over z. Here I have ln. I didn't talk about ln yet, except in this video. It's log base e. But again, I see, I have addition. I have these coefficients in front. First thing I'm going to do is bring those coefficients up like that. 8 squared is going to turn into a 64. The plus is telling me to write that as a product, so I have ln of 64z to the 5th. So these logs can be complicated, but they're going to be essential for solving certain kinds of problems. And my next video will be on that. So give this a watch, pause it, take your time, and check it out.